Next we'll work for practice 15.2. My PowerPoint output was a little messed up here, but I'll read it to you. Consider the equation CHCl3, so this is chloroform, plus Cl2 yields CCl4, carbon tetrachloride, plus HCl. The initial rate of reaction is measured at several different concentrations of the reactants with the tabulated results shown here. From the data determine A, the rate law for the reaction, and B, the rate constant K for the reaction. We see here for chloroform, if we double the concentration, we double the rate. So we can assume that we're first order with respect to the chloroform. With respect to the chlorine gas, we have an unusual situation. We see that for the Cl2, if we double the concentration, the rate only goes up by 1/2. So that would give us an unusual rate law where the rate is equal to K times CHCl3 to the first times Cl2 to the half. Now, in order to verify the rate law that we determined by observation, we'll do the calculation to see if it is indeed correct. So our formula is the rate at point 2 over the rate at point 1 is equal to the rate law at point 2 over the rate law at point 1. So we have the concentration of the species at point 2 divided by the concentration of that species at point 1. So for chloroform, we pick our points. 0.0069 is our rate at point 2 divided by 0.0035 is our rate at point 1 is equal to K times 0.020 to the N. That's our concentration at point 2 divided by K times 0.010 to the N. That's our concentration at point 1. Now we're solving for N. The K's cancel and we get 1.97 is equal to 2 to the N. Now we need to take the log of both sides. So the log of 1.97 is equal to the log of 2 to the N. So the log of 1.97 is equal to N log 2. So we get N is equal to the log of 1.97 divided by log 2. So that's equal to 0.294 divided by 0.301 is approximately equal to 1. So we see that the exponent for the CHCl3 would be 1. So our rate law with respect to that species has an exponent of 1. Next, we'll do the same thing for the chlorine gas. So our rate at point 2 divided by the rate at point 1 is equal to K times the concentration of chlorine at point 2 to the N divided by K times the concentration of chlorine at point 1 to the N. So we get 0.0098 divided by 0.0069 is equal to K times 0.0020 to the N divided by K times 0.010 to the N. So we get 1.42 is equal to 2 to the N. Taking the log of both sides, we get log of 1.42 is equal to N log 2. So we see that N is equal to the log of 1.42 over the log of 2, which is equal to 0.152 over 0.301, which is equal to 0.50. So overall, our rate equation then is equal to K times CH CL3 to the first times CL2 to the 1/2. Part B for this 4-practice problem asks us to solve for K. So let's take the rate equation we just derived, where the rate is equal to K times the concentration of CHCl3 times the concentration of Cl2 to the 1/2. Okay, and so let's solve for K. So that gives us K is equal to the rate over CHCl3 times Cl2 to the 1/2. So we can take a data point and plug in all of these species. So we get 0.0035 molar per second divided by 0.010 molar times 0.010 molar to the 1/2, and so that gives us 3.5 to the negative 1/2 molar times second to the -1.